Well, as an unwilling badger keeper, you're also a keen astronomer, and with the days getting shorter and shorter, there's never been a better time for stargazing.
Our astronomer Mark Thompson takes a group of one-show viewers out into the night.
For thousands of years, we have been staring at the night sky, trying to make sense of it. But what stops those stars and planets from plunging down onto us, and what keeps us safe down here? The answer lies with one of the great eureka moments in our scientific history, when it said an apple fell from a tree and changed our view of the universe. The apple was in this garden at the family home of Sir Isaac Newton. Seeing it fall led him to write his scientific masterpiece, Principia, in 1687. It revealed his groundbreaking discovery, gravity. Newton realised that it was the force of gravity which pulls objects together. The heavier the object, the stronger the pull of gravity, which is why the small apple fell towards the mass of the Earth. But his next question was, what if gravity extends to the moon and beyond? There's a lot of other stuff in the impact. I've invited a group of local one-show viewers to brave the cold and take a look at the night sky to find out what Newton discovered. I mean, do you realise how important he was to astronomy?
I just know about gravity and the apples, and that's mostly what I've been taught at school. And
I mean, I've had people up in the church who've said, wasn't he the bloke who invented the apple, one of the kids?
The Earth is a very massive object, so there's a lot of material here compared to the Moon, and the Moon is much smaller, and there's a lot less material up on the Moon. So what effect is that going to have on the atmosphere around the Moon?
It'd be pretty thin, wouldn't it?
Yeah, that's right, yeah. The force of gravity here on the Earth is a lot stronger, and because it's a lot stronger, that means that it actually holds on to the atmosphere, the gases that surround our planet, and means that we can actually survive here. During the first moon landing of 1969, they experienced how the gravitational pull on the Moon is 1/6 of that on the Earth. But when it comes to Jupiter, it's a very different story. It's the largest planet in the solar system and has the strongest gravitational pull. Well, we're fortunate because at the moment Jupiter is at its closest since 1963, which makes it really, really bright. And can you see, that's actually a planet Jupiter. The gravity of Jupiter is large. The benefits to us is that it stops things hitting us.
Like solar winds and all that?
No, something else. Ah, yes, asteroids. It's like a sort of celestial hoover, if you like. It's kind of sweeping up all these bits of debris that are flying around space. In July 1993, comet Schumacher-Levy 9 collided with Jupiter. It proved that the sheer force of Jupiter's gravitational pull was so strong it pulled the comet off course. Something else that's prominent this time of year is the constellation of Cygnus. If you look straight over your head, can you see the W shape of Cassiopeia just there? Yeah?
Oh, yeah.
Just about make out those corner two stars there. If you take these two stars and follow them down, all the way down towards the horizon and stop at the first fairly bright star you come across, that's a star called Deneb, which is in the tail of Cygnus the Swan. But the reason we're looking at Cygnus is because within the constellation of Cygnus, in the boundary of the constellation of Cygnus, is one of the first black holes that was discovered. Any idea what a black hole is?
Is it a collapsed star?
Spot on, collapsed star, and that's why we're talking about black holes, because, again, it's something that gravity has caused. Stars are immense compared to planets, and when the most massive ones die, gravity overcomes all other forces and causes the entire star to fall in on itself, creating a black hole. That's pretty amazing stuff, isn't it? Yeah. And that black hole is somewhere broadly that direction up there. It's called Cygnus X1. Kind of sends a tingle down your sort of back your neck a little bit. We're here at Isaac Newton's home, or the place he was born. He came back later in his life, and we're here talking about gravity and the other things that we've discovered.
Yeah, it's quite awe-inspiring, really, isn't it? And makes you feel pretty insignificant.
Hugh, will you be out in your garden spotting Jupiter tonight?
Well, yeah, my friend Giselle gave me a telescope recently, so I'm going to be out there. So I look due south, is that right? Due south is the brightest star you can see. Due south, you can't miss it. Okay. It's that easy. Okay. Promise you. What if it's cloudy? You're stuffed. There's nothing you can do about it, you're stuffed. OK.
You've been doing it for a while, Hugh?
Well, to be honest, I'm not very good with these toys, and I did actually manage to spot the moon.
Oh, good work.
Yeah.
Good.
when it was full, and then I was convinced I'd spotted Mercury, but it turned out to be a scratch on the lens. So I'm a
Been
beginner.
done before many times.
Mark, there's been some exciting news from outer space.
There has, yes. We have discovered a planet outside our own solar system which is very similar to the Earth, and so the chances of life evolving on that planet are probably really quite high, so we think that's a good place to start looking for life.
This is actual footage. No, it's not. It's made up. It's made
Don't
up.
say
This
that,
is with
Mark.
Hughes telescope, this is.
Yeah, look, someone's drawn that.
But how far away, then, is that planet from Earth, would you say? Approximately.
It's something like 20...
No, specifically.
Exactly, to the centimetre.
Yes.
It's something like 20.5 light years away.
Wow.
Now, to put that in some kind of context, we've got some little marbles here representing the Sun and the Earth. Now, if they were 7/1000ths of a centimetre apart...
Small, right.
Quite close.
Yeah, close.
Then the planet Gliese 581G, which we're talking about, would be all the way over there to where our props man, Dave, is standing there in a very Herculean fashion in the cold, pointing out with a model of the planet.
Poor Dave.
Oh, he must be freezing.
He's been out there since 4
He's been there for ages, hasn't he?
Yeah.
Oh, look at him, and his arms must hurt.
He's stuck.
What's it called again?
Gliese 581G. It rolls off the tongue. It's
They'll
quite
come up with a
nice.
better name, though, won't they?
Probably not.
Dave
Well,
the
no,
Gleason,
probably not.
huh? Dave
Yeah, that's
Gleason.
him.
Call it Dave in our
When you say 20 light years, we hear light years all the time in describing this, but what is how do you know?
A light year is measured on the distance light can travel in 1 year. Now, light travels at a phenomenal speed. Any idea how fast?
Well,
18,000 miles a second.
600,000 kilometres.
36,000 miles a second.
It goes 300,000 kilometres in a second.
All right, double.
And travelling at that speed, it takes 20.5 years to get here to the Earth. Again, give it a bit of an idea of scale and distance. The Saturn V rocket, which sent man to the moon back in the 60s, if we tried to use that to get to that planet, it would take 60,000 years to get there.
So we're not going then?
Probably you need a few packs of sandwiches to get you there.
Yeah.
But what would life be then on that planet? Do we know? Have they any
We
idea?
haven't a clue. If the conditions are as we think they are, I mean, the average temperature is about -20, so it's a bit parky there. The year on the planet is about 37 Earth years, so you know it's kind of broadly similar to the conditions here on the Earth. Gravity is a little bit lighter, but because the temperatures are fairly similar, we think water can probably exist in its liquid state. So if it does, then the chances of complex life evolving are quite high.
What temperature is it up there?
-20 on average.
-20. So that's like Manchester.
Always.
Whole day in Manchester.
Pretty bang on. Is someone going to tell Dave he can come in?
Yeah,
I think
he
he's still.
can
That's probably -20 up there, I think.
Probably freezing.
Well, thanks, Mark, and thanks, Hugh, for popping in.